So we've talked about the general acid definition that an acid can be represented by producing H plus in solution, and that a base can be defined as something that produces OH minus in solution, and that a typical thing that happens with a lot of acids is that H plus and that OH minus come together and form water. And so we're just going to do a little predict the products with that in mind, and hopefully it'll help you as we get into titrations understand that when a acid and a base come together, there is the potential for water. And we call the other ions, the ones that were not becoming water, spectators. So let's take a look here at some examples of predicting products. You're going to take an acid, which has that leading H, and you're going to take a base, which has that OH, and you're going to put those together to form water. So if you think about it, right, the H and the OH come together, and that's the same as water, H2O. All right, so those will come together, and then in addition to that, the spectator ions, in this case, the nitrate and the potassium, are going to come together as well. We always put the metal first, and charge balance wise, just like this is a +1, right? The H has a charge of +1, and the hydroxide has a charge of -1. So they neutralize out as water. The potassium is also going to be +1, remember, right? Here's potassium with the +1. And the nitrate has a -1. So they come together nicely as well for the KNO3. All right, so we balance equations. So if there's H2SO4 plus KOH, now there's two H pluses, and so there needs to be two OH minuses to counterbalance that. So we have an H plus and another H plus, and each one of those is going to get together with an OH minus and form water. So now we have two waters, right? So we have water and water, and then we're also going to have the K and the SO3. So the potassium, just as before, has that +1 charge. The SO3, the sulfite ion, has a -2 charge. Because of that, it's going to take two potassiums to counterbalance that SO3 minus 2. So what we're seeing here then is the result of all that balancing out. So this would basically make two waters, right? And two of those potassiums need to sort of extinguish that SO3. So that's why there's two potassiums and one SO3. All right, so we try it here again. This time the base is the one that has two OH minuses, and because of that, we needed two HCl's. We needed two of the H pluses, one for each of those, and then also the magnesium is going to want to get together with the chlorides, and there's two chlorides. And again, this makes sense if you look at the charges, because magnesium has that +2 charge and the chloride has that -1 charge, so it would take two chlorides to satisfy that magnesium. So, um, right, so we're looking at this as if it were two CO minuses, and then all that would equal 0. So in the end, this becomes two waters and one MgCl2.